Hi there. For this video, we'll be talking about how to factor quadratic trinomials. So before we go on to our examples, let's first have this illustration. If we have x plus a times x plus b, and we apply the FOIL method, then we'll first have so this one is x squared plus the outer terms, which is this two. This will give us bx plus the inner terms, which is this two. That will give us ax, and the last term, which is these two. Then after this, since bx and ax are like terms, assuming that a and b are real numbers or constants, we can write this one as x squared plus a plus b times x plus ab. And so this is where the concept of factoring quadratic trinomials comes. So basically this is a trial and error, and the main strategy that we would do is we would inspect first the last term, which is this one, check out its factors, and when we add those factors, its sum must be this middle term out here. So it's still kind of hard to visualize things with just this one, so we'll have an example. So our first example is x squared plus 7x plus 12. Now again, the first thing that we would do is we would inspect the last term, which is 12. So let's list out the possible factors of 12. So we can have 12 times 1, or we can have 6 times 2, or we can also have 4 times 3. I think that's only it. And from here, what we do is we add these factors and see which would be equal to this one. So adding this will be 13, so this one is wrong. Adding this would result to 8, so this one is wrong. And this one, 4 plus 3, would give us 7. So this matches with the term in the middle. So we can write this one as x squared plus 3 plus 4 x plus 3 times 4. So clearly this is similar to the one that we had a while ago. And from here, we can conclude that the factored form of this trinomial is x plus 3 times x plus 4. And so that is how we factor quadratic trinomials. Now to verify, if we apply the FOIL method out here, then we'll have the first term, which is x times x, the outer term, which is 4 times x, the inner term, which is 3 times x, and the last term, which is 3 times 4 or 12. When simplified, this results into this one. So let's have another example. Let's have x squared minus 9x plus 20. Again, what we do is we inspect the last term out here. So we've got 20, and let's try to list out its possible factors. So we have 20 times 1. We can also have 10 times 2 and 5 times 4. Now from here, we try to add these factors and check which would result to negative 9. So 20 plus 1 will be equal to 21. So it's not this. 10 plus 2 will result to 12. So it's not this one. 5 plus 4 will result to 9. This one is 9. But it should be negative. So what can we do to make this negative? Well, note that we can actually also multiply negative 5 and negative 4, and this would result to 20. So when we add negative 5 and negative 4, this would result to negative 9. So this one is the correct one. So we know that this one would be equal to x minus 4 times x minus 5, since these are the factors that we have found. You can verify that when we apply the FOIL method, this would result to the same trinomial. Let's have this third example. If we have y raised to 4 plus 5y squared minus 6. Well, this might seem scary at first since we are now dealing with a variable raised to the 4th power. But note that we can actually write this one as y squared plus 5y squared minus 6. So let's move this one first to save some space. And from here, what we can do is we can let x be equal to y squared. So this one will be equal to x squared plus 5x minus 6. And we can now apply again the method that we had a while ago. So focusing on this one, listing out its factors, we can have 6 times 1. Oops, this is negative 6. So we can have negative 6 times 1, 6 times negative 1. What else? Negative 3 times 2, or 3 times negative 2. And from here, we inspect which one that when we add up will result to 5. Clearly, it is this one, since 6 plus negative 1 will result to 5. So we take this one. So we know that this one will be equal to x plus 6 times x minus 1. And going back to this one, we write this as y squared plus 6 times y squared minus 1. From a previous video, we know that we can still simplify this one, since this is a difference of 2 squares. So let's move this one. Applying the concept of difference of 2 squares, you can verify that this one is equal to y squared plus 6 times y plus 1 times y minus 1. So that is the answer for this one. Now, as an exercise, Let's write it here. You can work on this one. C raised to 6 minus 3z cubed minus 10. Basically, you'll apply the idea that we used a while ago. Let's move on to our final example. If we have 3a squared minus 2a minus 5. No problem here is that our leading term has a coefficient. So how do we solve this one? Now, a useful method that we can use here is what we call the slide and divide method. So basically, the first thing that we would do is we would slide this coefficient out here into the last term. So we'll multiply it here. So we'll have a squared minus 2a minus 5 times 3. And simplified, this one is equal to minus 15. And now we can apply again the trick that we did a while ago. So focusing on this one, we'll have negative 15. Listing out its possible factors, we have negative 15 times 1 or 15 times negative 1. We also have negative 5 times 3 or 5 times negative 3. Upon inspection, the correct partner is this one, since negative 5 plus 3 is negative 2. So we know that this one would result to a minus 5 times a plus 3. Now, are we done with this one? Not yet, since we have only done the slide part. The next thing that we would apply is the divide part of this method. Basically, what we slided a while ago, which is 3, we divide it now to these two. So dividing 3 into this one, we'll obtain a minus, since 5 over 3 cannot be simplified, we'll just write it as 5 over 3 times 3 over 3 is a plus 1. Now, is this the final answer? Not yet, since if we have a fraction, in this case we have 5 over 3, what we do is we slide back this 3, or the denominator, back to this one. So we will have, sliding it back, we'll obtain 3a minus 5 times a plus 1. And this one now, out here, is the final answer. Now, just an additional exercise. Again, you can try to work on 2b squared plus 11b plus 15. Yep. Basically, you'll apply the slide and divide method, and after you answer this two, you can comment it down below, your solution or your answer, so you can verify. And so that's all for factoring quadratic trinomials. Thanks, and that's all for this video.